Today I will be trying to show you how to integrate a function. We'll start with this one here. The first thing you want to do is add 1 to your exponent, which gives you x cubed. And then you divide by your new exponent, which was a 3. So divide by 3. And then you have your plus c. If you want to check your work, you take the derivative of it. So you multiply it by your exponent. That cancels. Subtract 1 from your exponent. You get x squared, which was your original equation. The derivative of a constant is nothing, so that goes away. If your problem has a polynomial in your integral, let's say a plus 5 dx, then you do the same thing, except you integrate each one separately. So right here, we're going to get the same answer, x cubed over 3, from our previous solution. And then you add the antiderivative of a constant, which is a 5. And the antiderivative of the constant, you simply have to add an x to it. And then plus c. If you want to check your answer, again, take the derivative of it. So 3, that cancels, minus 1, x squared, plus 5. And you see you get the same thing as the top. Another way of solving these is using u substitution. Let's say we have the antiderivative of 5 over x dx. You should be able to recognize this as a ln. The derivative of ln of x, you should know, is u prime over u. And so if we substitute make u equal to x, and the derivative of x, or our derivative of the u, which is the x, is equal to 1. So if we substitute that into our function, we get the antiderivative of u, and then we have to try to get a 1 in the top. And to do that, you have to divide by 5, and that reduces that. But whatever you do to the inside, you have to do to your outside. So on the outside, you simply leave the 1 over 5, and that carries over here also. And now we're left with 1 on top. So our 1 is equal to du if we substitute, and that is du, which is also u prime. I'll write it as u prime since that's what our equation is over here. So whenever you have the u prime over u format, the antiderivative of that would be ln of the absolute value of u. So taking the antiderivative of that, you keep the 1/5. Then you have the ln of u, absolute value of u, and then your plus c. And then you finish off by substituting back your function, which is to get rid of the u. So you're left with 1/5 ln of x, substituting because they're equal, and then your plus c. You have to be able to recognize these because they're shown a lot. It's the u prime over u, and you simply have to adjust by removing a constant from your top or the bottom, and you just take it outside of your integral so that you left with the format of u prime over u. A harder, more challenging problem. Here's an example where we will have to use again the u substitution method. That's a 1 squared dx. So if we make our u equal to e to the x plus 1, and du, or the derivative of that, we should know it's equal to e to the x, because the derivative of e to the x is e to the x, and the derivative of 1 is nothing, so that goes away. And if you go back and you substitute, the u substitution, you have e to the x is your du, because they're the same, and then times your u, and it's squared right here, and then you take the antiderivative of that. Let me write it with the du on the side. And to take the antiderivative of that, you pretend it as if that were an x. You do the same thing. You add 1 to your exponent, so you get u cubed over 3, and then your plus c. And to finish it, you simply have to go back and substitute your u's for the function. So you get e to the x plus 1 cubed, since that is the u, and then you divide by the 3, and then you have the plus c. And that is how you do indefinite integrals. For definite integrals, you follow the same process, except in the end, instead of having the plus c, you have to substitute your bound. So let's say we have from 0 to 1 antiderivative of x squared. The first thing you do is you take your antiderivative of it, so you add 1, so you get x cubed over 3, and then you do your bound from 0 to 1. Right here we don't have the plus c since we actually have the bound. So what you want to do is substitute your 1 for your x's. So we'll have 1 cubed over 3, and then you subtract when you substitute your bottom bound onto your function, so you get 0 cubed over 3. And then you simplify 0 over 3, that gives you 0. And then 1 cubed is 1 over 3, and that is your solution. And you do the same process for any function that's a definite integral. You just take the antiderivative as we did before, and then in the end you just have to substitute your bound.